to the State of HABs Mitigation. This is a webinar series, just two sessions this year, but a continuation of several years now of collaboration between Cleveland Water Alliance and the Great Lakes Commission's HABs Collaborative. Today's session will be focused on innovations in nutrient mitigation. So really thinking about the cutting edge of technologies and solutions that are working to reduce nutrient pollution in our waterways. Encourage folks throughout to be submitting questions. We'll have time for Q&A at the end. And we'll be going first to the Q&A tab, which sometimes you may have to click more, the little three dots at the far right end of your toolbar in Zoom in order to access. Just want to differentiate between the chat, which folks are also free to use, and the Q&A. That's where we'll go to first for questions. It is also possible for our panelists to respond with text during the session if they have bandwidth and time. That's not necessarily going to happen, but just to make sure you get your questions answered, please do use that little Q&A box to enter them. And with that, it's my great pleasure to introduce our moderator for today. Dr. Sylvia Newell is the director of Michigan Sea Grant, and we're very fortunate to have her be kind of taking the reins for this panel discussion. So with that, I'll hand it over to you, Sylvia.
Thanks so much, Max. Just a little further introduction of myself. I'm also a professor at University of Michigan, but before I was there, I was in Ohio at Wright State University, so pretty familiar with some of the work going on in Ohio, and I might mention it a little bit later. I'm thrilled, though, to introduce to you our two panelists. Parker Cohn is the founder of Performance Resource Management, and Joel Weber is the founder and chief executive officer of Lake Water Nutrient Capture. So today I'm going to ask them a series of questions. I might chime in myself, and before I do that, I'm going to kick it off with a sort of introduction on why we should care about this in general. And I am assuming that for almost everybody on this call, this is going to be review and things that you already know. So please forgive me. And if you happen to learn one thing, I'll be thrilled. But if you already care about HABs, you probably know a lot about this already. As I'm sure you all know, right, we care about HABs because they are harmful to human health and they are getting worse. So across the planet globally, like this is not a North America thing, this is an everywhere, well, maybe except Antarctica thing. We have more humans, and as we have more humans, we have more nutrients, especially reactive phosphorus and nitrogen, going out into the world, exacerbated by warming temperatures, especially warming shallow lakes and shallow areas along coastlines. We're getting these problems with harmful algal blooms. The ones that we tend to focus on in freshwater tend to be cyanobacteria, and we care about them because they create toxins that are harmful to humans and pets and cows. But wherever you are along the continuum of freshwater to coastal water, it's an increasing problem globally. And what do we mean by nutrients? Well, specifically, we mostly are talking about phosphorus and nitrogen. And when we're talking about Lake Erie and the harmful algae blooms in the Western Basin, the Great Lakes Water Quality Agreement, Annex 4 of that, has a target of a 40% reduction of P loading to Lake Erie compared to the 2008 benchmark. This happened in 2012, and then in 2015, the US EPA released a bulletin that advocated for treating harmful algae blooms and eutrophication to have a dual nutrient control strategy. In other words, to expand that to nitrogen in general when we're talking about harmful algae blooms. We don't have reductions in targets in the Great Lakes yet, but we didn't have the data to create it in 2012 either. And now we probably do. There's been enough monitoring and looking at it. And in fact, it's something that the IJC is taking under consideration and starting to work on. The International Joint Commission.
So there is strong evidence that the amount of phosphorus
okay, so there's
and when people
there's strong evidence that the amount of phosphorus going in from Maumee River into Lake Erie is a strong driver of the harmful algae blooms. I unfortunately used a slide from my class in which I had recorded it, so that's why you hear my voice starting to talk about it. But you can see there's this strong relationship between the Western Lake Erie blooms and the amount of soluble reactive phosphorus that's coming in from the Maumee River in any given year. This is an old graph from, I feel old saying it's old, but from a Doug Cohn paper in 2014 showing this pretty strong relationship between, especially over here on the left, right, the Western Basin cyanobacterial biomass, the wet biomass in milligrams per liter, and the relationship with the Maumee River load. And an R squared of 0.8 is like not something you see that much in ecology. So it's very exciting when we get a strong number because it means we have a strong indicator of what's really going on, right? And so that has led to the focus specifically on spring SRP loading, soluble reactive phosphorus loading into the Western Basin, causing the harmful algae blooms there. So why should we care about nitrogen then if we already have this really strong relationship with phosphorus? Well, we care about it because nitrogen drives cyanobacterial toxin production specifically. Like if you look over here on the left, where I hope you can see my arrow, the microcystins, you can see that these liver toxins, hepatotoxins, have 10 nitrogens for every molecule of microcystin and no phosphorus, which means that it has to be nitrogen and nitrogen availability that's really driving cyanobacterial toxin production and how much they can make. And so it's a good reason to care about it, especially because we're having more and more reactive nitrogen in the world. So we talk about soluble reactive, not phosphorus. The corollary for that in nitrogen is reactive nitrogen, and it includes ammonia, urea, and nitrate. And as we have increasing world population, right, it's actually increased because we figured out how to fix nitrogen, or the Haber-Bosch process that turns the nitrogen we breathe in the air, that's 79% of the atmosphere. It's the triple bonded, N2 gas. As we convert that into fertilizer, we have more people, but it also means we have a lot more reactive nitrogen. And we're putting just so much nitrogen fertilizer on the ground globally. And that means that here in Lake Erie, our cyanobacterial harmful algae blooms in the lake are not the same as they used to be. Back in the 1960s and 70s, they were still cyanobacteria, but the dominant species were nitrogen fixers, where they really relied on pulling nitrogen out of the air. And as post-World War II, we've added so much more nitrogen fertilizer across the globe. Here in Ohio and Michigan and Lake Erie, Canada, like the consequences of that are that we have shifted to these microcystis dominated blooms, which are a form of cyanobacterial species that don't fix nitrogen. They don't have the genes for it. They can't do it. And they do produce these microcystin toxins. Now that when I say dominated, they're not the only thing in the bloom. About half of the species in the bloom are not microcystis. There are a lot of bacteria, and you can switch to later in the fall being nitrogen like limited and therefore having some nitrogen fixation come to play in other species. But the peak bloom period that we're talking about, when you still have had nutrients, feeding from the beginning, that's where we see the microcystis dominance. And so that means that if we look at the spring total phosphorus load, the spring SRP load, and the spring, it's called total kildall nitrogen. It's basically just the non-nitrate nitrogen. And all of these data come from the Heidelberg Tributary Loading Program in Ohio that does the monitoring for the Maumee River. If you compare that to the NOAA HAB severity index for Lake Erie, this is just the spring load for the year compared to the HAB index. You can see that there's actually a strong relationship between TP, SRP, and TKN, although TP doesn't get focused on as much as SRP. But all of them are important. So why dual nutrient management? Why care about them both? Well, this was a paper by Chris Gobler, again, a while ago now, about a decade ago now. And those authors put together this really nice graphic that shows that basically where we are now in any hypereutrophic system is that we tend to have very high phosphorus and very high nitrogen. So we get this mixed assemblage of cyanobacteria, in our case dominated by microcystis, and we can get pretty high elevated toxicity. And I assume everyone would like us to be here where we have non-toxic strains and very small blooms. If you have more phosphorus and less nitrogen, you could theoretically go back to what we had in the 70s, where we have cyanobacteria that are nitrogen fixers, but even a less toxic but very large bloom doesn't sound particularly appealing to me personally. Or we could end up with a smaller bloom that's highly toxic. And all of those options to me personally seem bad. So I advocate for the dual nutrient management strategy that the EPA recommends so that we end up with smaller non-toxic blooms. All right, so how do we get there, right? That's what today's seminar is all about. So here we're going to hear from our panelists on some of the newer technologies, and in my case, less of a technology and more of a restoration approach that the state of Ohio has been taking. So Parker, if you wouldn't mind kicking us off, can you talk to us a little bit about your perspective on the evolving state of nutrient mitigation today, and how is new technology changing the conversation?
Of course. Thank you, Sylvia, for the background. And thanks, everybody, for joining today. I think for better or worse, something that is driving technology and changing the conversation is the increasing awareness and more significant contamination events that we're seeing across the country. So more people are aware than they ever have been before. And this creates opportunities for funding, creativity, innovation, different ways of looking at solving the problem. And I think it really fosters a collaborative nature. If there is a silver lining to increasing awareness and more of these events happening in the news, it's that each solution provider or each regulating agency is realizing that we can't do this alone. We need a multifaceted approach. We need to look at where is the point source coming from and implement solutions upstream. And we also need to be able to respond much quicker to these harmful algal blooms when they're happening at the scale that they're happening, to deploy solutions to the actual areas of toxicity. So I'd say people who are tasked to solve HABs are now looking for like a more comprehensive tool set, particularly how myself and my company participate in the solution is we regenerate soil with biology. And so we implement agronomy and engineering solutions to the core issue for us, which is soil health. But the side effects of that are increased nutrient availability for the plants and less runoff and higher quality surface water. So in the state of Florida, we got a grant, or we are a subcontractor for University of Florida to implement our solution on golf courses, which are considered point source contamination. They receive a high level of nitrogen, they receive a high level of phosphorus. And it's a real priority to correct the nutrient load at those sources. And I think that 10 years ago, our solution or our approach wouldn't have been recognized or even considered. But now, because of the increasing awareness and the increasing funding and the more collaborative and participatory nature, we have the regulating agency saying, hey, look, we have 1,200 golf courses in the state of Florida that can't be fertilized like they currently are for the next 10, 20, 30 years. So we had an opportunity to participate as being a component of the solution. So looking at the nutrient sources, where they're coming from, and the market forces that drive economic outcomes, 1,200 golf courses in the state of Florida, high economic driver. So we're getting a lot more perspective across the board. I think that really creates opportunities for solutions and a more holistic approach. And I'll pass it off to Joel, who focuses more on the actual mitigation of the blooms themselves.
Appreciate that. So I find that there's a growing strong public demand for change. People are tired of the inaction and leaders are looking for new solutions. It's important for us to address nutrient runoff at the source, but there are very few viable solutions for addressing runoff in water bodies at scale. Many current solutions just shift nutrients around in the water body instead of actually removing it. We consider ourselves the last line of defense, implementing a service using absorbing materials mounted on a barge that remove dissolved phosphorus directly from the water. The byproducts that we generate can be captured and resold as product depending upon the purity of the water body as tricalcium phosphate.
Thank you both so much. And you're absolutely right that once the nutrients make it into the water body, it's very hard to just take them out, and things mostly do move them around. So that's why, in this case, the state of Ohio has really focused on nutrient mitigation from agricultural runoff before it ever makes it to the lake. And there have been a number of strategies that have been employed under the H2O Ohio Act. But one of them that I have personally been involved in is the wetland program through Ohio DNR, in which they have spent really almost $200 million creating wetland projects. It includes 515 wetland projects across the state, 378 of which are completed, and about 20,000 acres, 20,500 acres of wetland and habitat restoration. And my part has been to be part of the wetland monitoring program. As when I started, I was in Ohio as a professor, right? And we were working on monitoring the wetlands to see how good they really are at reducing nitrogen, at reducing phosphorus. And so not all of these projects are being monitored, only a handful of them are, but the average of the ones that are being monitored have shown that all of the projects have an average retention of about 2 pounds of phosphorus per acre and about 50 pounds of nitrogen per acre. And if that's true across the entire 20,000 acres that are being or have been restored already, that would equate to 40,000 pounds of phosphorus held back and about 1 million pounds of nitrogen. And so that's just really a huge amount of nitrogen and phosphorus. And I think personally, it's always better to reduce the nutrients at the source if you can. And if you can't, that's where we really need these other technologies. And so, maybe wetland is not as cool and sexy as a technology, but it is pretty great in terms of habitat restoration as well. So if you're someone who's thinking about it, I encourage you not only to think about the tech, but also think about some of these like low tech restoration efforts to help where it's possible. Once it's already made it into the lake. Yeah. All right. So thank you both so much for those answers. Moving on to our next question. I am wondering if you can tell me what you think the limitations, risks, and barriers are that really stand in the way of implementing these solutions at scale, and what have you seen cause promising mitigation projects to fail? Joel, would you mind kicking us off?
Sure. So I have found that there's a clear difference between municipalities that are ready to acknowledge the issue and budget allocations that show that they're committed, and those that just only give lip service to the solutions. States like Florida and Ohio have acknowledged the scope of the challenge and are actually committing, like you had mentioned, funding to planning and implementation of projects. Many leaders are see addressing this issue as nice but not needed, or it's just not a high priority for them. So they lack the action to come back. They lack action, and it comes back to bite them. An example of that is the multi-billion-dollar lawsuit in Manitoba that's going on right now with the wastewater treatment plant for Winnipeg, and the many, many, many years that they've been delaying the upgrades to the wastewater treatment plant, which has been discharging well above their effluent limit for the permits, directly correlating to major blooms in Lake Winnipeg. And I'll pass it off to Parker then. Sorry.
All right, good points. Thanks, Joel. I think when we zoom out and we go from looking at solutions to looking at kind of what are the barriers to our solutions working together and actually making a notable difference on the measurements of phosphorus and nitrogen that are in our bodies of water, is we have a really complicated, multifaceted problem that people want to see a simple one-size-fits-all solution. That's kind of like humans are programmed to look for, okay, problem solution. Well, this is a problem that, my technology reducing, fertilizers upstream by 40, 70%. That's not going to be enough, and the inertia of that solution is going to take time for the market to adopt it, for the economics to make sense. And meanwhile, we need to implement, solutions like Joel's, and where we have the active high levels of phosphorus and nitrogen, where the damage is already done. We need to be able to see the entire picture. And I think I deal with this a lot. I do some work with state and municipalities, and when we're looking at one of these more complicated problems, it's really about understanding the problem fully before we move towards a solution. So we know where the nutrients are coming from. uh, you know, a single solution towards reducing those is not currently economic, or is not, capitalism isn't curing that problem for us. So we need regulation, and we need cleanup exercises, and we need the 911 implementations of phosphorus and nitrogen mitigation to slow these blooms down where they are causing environmental and economic harm. I think it's really, really important. And that is, another risk barrier limitation is, our solutions, when implemented properly, will provide that environmental benefit and that economic benefit. The two are in hand. And when we don't have an environment that can support us, anymore, be it, agricultural production, or be it, we're destroying ecosystems downstream that we rely on, and our planet relies on, how do the economics look then? And I think having zooming out, seeing the bigger picture, not looking for a one size fits all solution that solves this immediately, and really understanding the problem. I think those are the main risks or barriers that stand in the way of our collaborative effort to resolve and find solutions here.
Thank you so much, both of you. I really want to echo what both of you were saying about there is no one size fits all solution. Even subwatershed to subwatershed, but also lake to lake. And especially with things like once the nutrients make it into like phosphorus binding, for example, I had the opportunity to work in Grand Lake St. Mary's after the last two treatments of both alum and Foslock, which are both phosphorus binders, but only in the swimming enclosure. And unfortunately, neither one worked for very long because the swimming enclosure is actually open to the lake and the water can exchange. So if you have a lake that doesn't have a huge amount of new phosphorus coming in every 3 days, it works super well. But unfortunately, if you do, it brings back the algae with it, right? If you're dumping a bunch of new phosphorus back into that area of the lake. And so I just want to encourage people, if you're not thinking about Lake Erie, if you're thinking about your own, inland lake somewhere that you really care about and are working on, make sure one size does not fit all, right? You have to think about how shallow your lake is, how deep your lake is, how much nutrients you have coming in, and in what way are they coming in, and to really, customize your solution. All right. So, Joel, tell me, what does the future of nutrient mitigation look like, and what could successfully scaled implementation of this technology enable?
Sure. Well, we need to get to a point where the issues are triaged properly, like you were saying. If everything is scaled up properly, people wouldn't need our service, ours particularly. If long-term systemic solutions were in place everywhere, then we wouldn't need band-aids anymore. The reality is that there's always places where pollution is getting through, and we need to create spaces for upstream solutions, especially in places like drinking water reservoirs where special focus is required. Our company is really designed around being an emergency service for these communities. Think of it like you have a hospital that's running on grid electricity, and in the middle of a storm, it goes down, you have no power, and you run on a generator. And it's your last resort, right? It's going to be a little bit more expensive, but it's immediate. It happens, and it's mitigating while you're fixing the bigger issue. That's where we really find ourselves with the problem with nutrient mitigation. Is we're that last line of defense that can be implemented rapidly and quickly to capture the phosphorus once it is in these lakes, because there are a lot of solutions for capturing it at source or before it gets into the water, but very, very few solutions that remove phosphorus at scale in a big lake. And that's where we really kind of position ourselves, is we're that generator that, people can, put in place to provide that valuable and much needed relief and service, while these larger intentional and targeted programs are put in place on land that, are point source. So then, like I said before, if everything functions the way properly, you remove the phosphorus issue entirely. Well, not entirely, but you largely mitigate it before it gets into the water, and then you don't need our service. But the fact is, there's always going to be phosphorus in the water, and it's going to be a big problem moving forward because of how our communities are growing, so forth. Parker, I'll pass it on to you if you want to add.
Yeah, really, really good points there. And I think to emphasize one of Joel's points here is if we have a sustainable system working, his solution isn't necessarily required, but we're humans. There's a human factor. And our track record needs to be able to have these technologies that are deployable fast when we have an issue. So back to the question, and when I go back and I look at what the future looks like for nutrient mitigation, or any sort of climate tech, and we'll speak specifically to nutrient mitigation here, is I really see where mining and reuse of nutrients is a key component as part of the future. And that's one of the reasons I like Joel's solution so much, is where we're solving the problem by removing those nutrients, where they're causing a problem, but then we can recycle them and reuse them. And you have this real circular economy effect that begins to take place. And once that begins, once we're taking and mining the phosphorus, where it's a problem, the nitrogen where it's a problem, and we're able to put that back upstream in a more sustainable method, say, incorporating soil regeneration and, regenerative management practices in agriculture. Like, now we are not just recognizing environmental value, but there's economic value at the bottom, of that. And that's where we see this, I see the circular economy picking up. I see the value of the environment being actually, put on an economic scale that can create more funding for these solutions and create a virtuous cycle here, where, yes, there is an opportunity cost of remediating a polluted environment. It's money. But if you can advance the alignment, a clean environment, a healthy economy, systems, and to the communities, that creates resilience in our communities and our society. And I really want to emphasize that we cannot get there without investment and without cross collaboration.
Can you talk about some of the barriers that you see to that happening? For example, there's a lot of dredge material that's been pulled out of Lake Erie that has actually been shown to, when you mix it with other soil, improve corn yields, for example, but there are a lot of heavy metals in it, or it needs to sit for a while and have the toxins break down in it. So can you talk about some of the barriers to doing that, and some of maybe new, currently not existing technologies that would be needed for that to be able to happen?
Joel, would you like to kick this one off?
Well, that's a little bit outside of my wheelhouse when talking about those, but I do know that dredging, with a lot of these technologies, there is a specific use for each of them. It's like you said before, it's not a one use fits all. Oh, did I lose you guys?
No, we still see you.
Oh, sorry. My computer was telling me it was a little bandwidth. So there's a point in time for each of these, and there is a lot of valuable nutrients within those that soil that's being reclaimed. But the reality is that dredging itself can be very destructive in its purpose, and it's very limited to where it should be applied. But then the spoils that are brought out, I'm pretty sure that there's a lot of really smart individuals that are creating procedures and uses to reuse and capture the phosphorus in that material. My biggest approach is whenever I see industries where there's a lot of waste, like for example, we'll say in the recycling industry. Okay, so the recycling on the surface is a great idea. Everybody talks about it, and it's great in practice. But the dirty secrets behind the industry, and how very little is actually recycled, and how there is still a lot of waste. And rather than having companies having to deal with waste, I look at what are the opportunities with that waste that is being generated. How can we leverage that? Because that's where you can make a real difference, is leveraging what somebody else wants to throw away. And a case in point with the spoils from Lake Erie, a lot of people would consider that to be waste. Well, I look at that and be like, there's value there. It's just figuring out how you can extract that value and to use it for a better good. There's a lot of heavy metals. Well, we're talking about rare earths and also a lot of different kinds of metals. Well, there's a way that we can extract that. It might not be viable just yet, but I'm sure that there'll be a lot more inspiration and companies that see that as a valuable feedstock that can be like, hey, this is perfect. We can reclaim that and offset what we are putting into the environment and also put it back into the economy. That's exactly how I approach the phosphorus with the water. Another favorite tagline that I like to use is, instead of just being the last line of defense, what we're actually doing is we're mining the water for phosphorus. We're removing that phosphorus. It's a valuable feed source because it's a critical mineral for North America that we're importing a ton of it. And so if we're able to even reclaim a portion of that that's being currently washed away into the water or being put into the landfills, because a lot of other technologies, they don't create a usable byproduct. It becomes a toxic sludge that then you have to dispose of in a landfill, or it sits on the bottom of a lake, which causes further issues with the environment. I see that as valuable resources that we can then further reduce our dependence on others and really push our own economy in that circular method.
Yeah,
Thank you
I've
so
seen.
much.
Oh,
Just I love that answer. Sorry, go ahead, Parker.
yeah, great one, Joel. I've seen a couple unique solutions that I have never been aware of. Like for instance, when the New York Canal was dredged up, a lot of contaminants, a lot of heavy metals. What was part of the solution there? They made concrete to reinforce seawalls with it, and so the heavy metals are locked up, or instead of causing more damage downstream, they were put to use in a way that was productive, that helped reduce erosion and supported the expansion of that economic driver, the New York Canal. Kind of not quite. It's a hard argument on circularity, but definitely a form of reuse and responsible management of toxic material.
Thank you both. Before we move on to answering audience questions, I'd like to give you a little opportunity to explain a little bit more about your own companies, your own technologies, and sort of the direction that you see them going in the future.
I can start this one for a second if you want to prepare, Joel.
Go ahead.
So one of the things that we're actively doing right now, and what is gaining economic attention in business, is reducing inputs from a chemical and loading perspective. Very relevant to this conversation, but also from a pesticide perspective. Think herbicides, fungicides, insecticides. Remediating the environment that causes a weak ecosystem, the soil, by regenerating it, creating healthier, more resilient plants, better drainage, to insects lay larvae in standing water typically. And so one of the side effects of improving drainage and soil health and root zone and nutrient absorption by the plants is you mitigate the environment that disease and insect pressure and weeds like to flourish. So in our projects across agricultural, the agriculture industry, with working with water districts and working with the university in Florida, is we're seeing ways to measure our solution in ways that we weren't necessarily pursuing initially. We got an award for our work at Oracle Park, where the San Francisco Giants play baseball in San Francisco, for reducing pesticides by 90% in 2022. And they were issued an award from California Department of Pesticide Regulations for their implementation of biological soil management and reducing the amount of pesticides by 90%. They were the first sports field to ever receive an award from DPR for reducing nutrients, reducing the pesticides. So that combined with the fertility reduction that we showed there, which was between 60 and 70%, those have created opportunities for us to implement our solutions at a larger scale, working with municipalities and working with water districts and working with, universities and the state of Florida to take that positive environmental and economic driver and implement it at a larger scale that's monitored by them in ways that they're measuring the quality of the water runoff and surrounding water bodies. And by reducing the inputs on the actual soil, making the turf in this example, or the fields of crops, more efficient and effective with their absorption of nutrients, we see less in the runoff and less environmental toxins downstream. Thanks, Sylvia. And Joel, if you'd like to tee it off. I love your Manitoba project.
Oh, thank you. Yeah, so a little bit of background about my company with Lakewater. Lakewater was kind of driven out of a background where I was involved in a lot of feasibility studies and assessing different projects that were going on here in the province, potentials. And one of the projects required that we mitigate phosphorus. And I did a lot of research on that. And, I came across a couple of different materials that really made sense. And it was very timely because up here in Manitoba, we have a big problem with Lake Winnipeg with the large algae blooms that are going on, the inaction with the wastewater treatment plant here in the city, that's really contributing to that. And so during that period of time, I realized, hey, with my engineering consulting background, it's like, you know what? I see how I can utilize these materials, and I know how I can leverage them so that it's a usable solution. And so initially I developed a solution for Lake Winnipeg, which is on the same scale and scope as Lake Erie. However, during that period of time, I realized that the local province was not so quick to want to move on that action or to implement a solution. It was more talk. And so we realized, hey, there are a lot of other lakes around North America and the world that are struggling with exactly this problem. And part of my background also is in farming. And so I took a page out of farming as to how do we do things on scale so that we can make it much more affordable and actually useful, practical. And that's when I really started leveraging Lakewater and realizing, we're that last line of defense. We're not advertising ourselves as that one solution, but we're that one solution that people can call on when they have a ton of phosphorus in a water body that they're dealing with. We specifically are really geared towards large lake water bodies, where a lot of existing technologies just are not practical or viable. That's where we pick up, because again, like with my farming background, I looked at it, okay, how can we implement something at scale versus something that works in a smaller pond? It's a complete change in dynamics on how you approach things. Yes, it will work for smaller water bodies, but from the get-go, it was designed for 1,000-acre plus water bodies, where the dynamics are totally different, and especially lakes that are on that shallower side. Like anything, the sweet zone is from 6 to 30 feet. You do get lakes that are deeper than 30 feet, but a majority of lakes in North America that are struggling with phosphorus, dissolved phosphorus, and specifically algae blooms, they fall within that range. And so that's where we saw the white space and realized, if we approach it much like an industrial scale of removing phosphorus, we can really make something happen here. And that's where, positioning ourselves as that last line of defense that can be implemented quickly with very little infrastructure. We're not the solution for everything, but we're the solution for right now while you can actually implement the broader scope of things to prevent the phosphorus from getting into the water.
Thank you both so much. All right, now we have some questions from the chat. I'm going to weigh in on the first one and then pass it off to you, and the others I'm just going to pass right off to you. So, first question is from Jonathan Wayrich, saying, knowing we have a much lower runoff concentration is currently than even a few years ago, how are we addressing removal of nutrients from the lake and sediment and microbial diversity recovery for restoring nutrient cycling? We're addressing these things, but I wanted to see what other solutions are being deployed. And so my answer to that is that yes, we do have a lower nutrient runoff loads in the last few years, but they've also been a lot drier. So we've seen about a 37% reduction on average in the last 5 years, which is almost that 40% goal. However, the water has been so much less, right? There's been so much less rain that we can attribute only probably about a quarter of that to the actual management practices that we've enacted, because the water itself, lack of water itself, is mostly what is contributing to the rest of that nutrient reduction. And we do know that when we have low nutrient loading years, when we have relatively dry years, the soils, the sediments in Lake Erie, this is my area of research, actually do a really good job at removing the nitrogen and phosphorus that are in the water column, and we have very small blooms. So I'm not sure we need that much bioremediation in the sediments. The microbial community is already pretty diverse and is already doing a pretty good job. But when you overload it with nutrients, the efficiency gets a lot lower. And so it's just not as good at removing nutrients. So we do have a pretty good, robust microbial community, but they just do a lot better when they're not overloaded. And so I think we just need to focus on less nutrients going into Lake Erie as the best thing that we can do, continue on the path that we're on, I think. Do either of you want to add anything to that?
Hi, Jonathan. I believe Jonathan is also through Aqua Action,
Yeah.
in the same cohort. No, you're doing awesome things on the microbial side and diagnosing the larger picture, and you're doing amazing work. There's a lot that's happening on the ground side, what you're specifically dealing with. Like there is a reduction in the nutrients that are going into the lakes, but then also, like you said, Sylvia, that there is also a reduction in rainfall and water. And if there's anything like what's happening here in Manitoba along the Red River specifically, we find that the nutrients are still being loaded within the aggregate watershed area, but that during the dry years they kind of percolate and sit there. But then when we have a flooding events, which happens really frequently in Manitoba, it's all of a sudden that we get a flush of all these nutrients all at once. So all that has been banked and now being flushed down the stream and ends up in Lake Winnipeg. So for example, on a low flow year, we might only have 3,000 tons of phosphorus that makes it down the Red River into Lake Winnipeg. But then, when a flood happens, all of a sudden now we have 15,000 tons. So a lot of that, you're right. Like there's a lot that's been done, but there's also a lot that's sitting there, and still a lot of stuff that needs to happen. I'll pass it on to Parker if you have anything to add.
I think both of you addressed that one, hit the nail on the head with it, particularly on nutrient loading and reducing that getting in. There's three that I hope we have time to get to. If you don't mind, I jump into this next question from anonymous attendee has listed a few questions here that are awesome, and many of the questions that we have to wrestle with in our own businesses and approach. So in your experience, how rigorous and extensive does your demonstration project need to be for a given technology or approach for it to be seriously considered by potential clients and regulators? And then I'm going to pair this one, and I think Joel can as well, to your second question. Have you done economic and societal cost benefit analyses for your technologies? So it has to be so much bigger than you think. I mean, I've worked on thousands of acres in agriculture, and I would say that it's not big enough until you're at 60,000, 100,000 acres, where the the you know the economics are making sense and the environmental impact, and regulation moves very slowly. So in the time for regulation to catch up with the actual needs of the environment and the economy, like, you have to be implemented with, our approach was to partner with the largest water district in the country and to get white papers, published by them. And so the economic and societal cost benefit analyses, for us, our approach has been to work with utilities, water providers, universities, states. The DPR attention helps, MLB attention helps, but it really takes a substantial amount of acreage and traction in order to be, considered by, customers, potential clients, regulators, municipalities. It's a long go. I've been at this full time for 10 years, and I started 15 years ago. And I'd say we're just starting to see the light at the end of the tunnel. This is our first collaboration working for a university that's starting up this year, and that comes almost 5 years after validation from public agencies. So make sure you factor in runway and timeline. And if you have a number in mind, say it's 10,000 acres or 10,000 hectares, or I'd say multiply that by 3 to 5, and that's probably more accurate, more representative of what you need to achieve to be seen as a solution through both the market and the regulators.
I'll jump in there and say that also the market, for a lot of markets where they value their water, we'll say, where they don't have very much water, and so they really value what little they have, they're very hungry. They're hungry for solutions. They see that what's working what's out there is not working, and so they're looking for new and upcoming solutions and companies. That's where I kind of fit in. We've only been around for a couple of years, and we're starting to get traction. We're starting to get stuff happening on our side as well. But people are really looking for that next thing that can help them solve a problem that's been long-standing. Like some of the municipalities that we work with around here, when I talked with them, they're like, hey, we were going to do an alum or a zinc treatment, and we were just so hesitant and reluctant to do it, but we just didn't have any other choice. We didn't have any other suitable solutions available to us. And thank goodness that we came across you, or that we heard about you, and we want to work with you. What can we do to work with you? We need a solution. That's been a lot of response that we've gotten from places that really, really struggle, that realize the problem that they have, and that they understand the gravity and the costs associated with that affecting their communities. Like the municipalities that I was talking about, they're getting daily calls from their constituents. They're saying, hey, look, we're paying big money here for these lots to be in this municipality, and all I'm seeing is green in the back of my backyard where it's supposed to be a lake. It's smelly, it's dirty, it's gross. My dogs can't go in the water because they're going to get sick, or they got sick. There's a real cost to that. And It really drives on real estate, tourism. That's something that's happened here in Manitoba with Lake Winnipeg. It's affecting tourism. It's affecting the fishing industry, both the commercial and the recreational. There's a huge amount of impacts that the dissolved phosphorus, specifically, I'm talking about because that's where I deal with, has really affected the society. And so there's a lot of people that are really anxious, to find a better solution because there really hasn't been many developments in that field at scale to affect change. Because it takes a big effort and a lot of money to change something this dramatic.
Okay, thank you both. We've got one more question from, again, anonymous attendee, and asking, in your views, what can local, state, and federal regulators do to remove potential barriers to advance proactive in-system nutrient mitigation? I don't know who wants to kick us off.
Well, it depends on the jurisdiction. If you're down in Texas, there is no barriers because they didn't realize they had a problem, and they don't have any laws in place to mitigate that. So depending upon where you are, it's hit and miss. But in terms of barriers that we've come into, sorry, Parker, I was going to jump in because of that. But in terms of barriers, I haven't come across too many barriers specifically with our products and services because something that's very unique about what we do is we don't leave anything behind in the water. So we don't touch the lake bed bottom. We're not leaving anything in the water. It's literally, we're just stripping the phosphorus out. And so we haven't come across too many issues within, talking with DFO or other regulators or states or provinces, because they see it as a net benefit. We're not impacting habitat when it comes to that. As soon as you start leaving things in the water, or you start touching the lake bed floor or affecting the habitat in other ways than just removing a pollutant, then they really have something to say about that. But other than that, I find that the biggest problem I find with regulations is not so much the regulations, but the lack of some of these bodies for actually implementing solutions or changes. They get so stuck in it. And I've seen kind of a change here in Manitoba where they went from a very closed off and not really wanting to adopt any changes to where they opened an entire department within the province that specifically geared towards how can we implement new solutions? How can we work with upcoming startups? How can we drive new technology and implement it in the province here? That's a major, major step in the right direction, because then through that, they're able to work with the different departments to reduce that red tape. There is red tape there for a reason, because somebody screwed up in the past, most likely. And so there's checks and balances. But it's about mitigating and managing that so it's not too overwhelming. It's actually, it's a spirit of wanting to move forward without damaging what you already have.
Points. And I have a little bit different angle here because I've been around a little bit longer, is I see, one, there's a funding issue, right? Like, we need more funding to implement more solutions. But two, once the funding is implemented and you have an actual feasibility study on scale that matters, we need help from the local, state, and federal regulators to deploy and implement. They need to be a partner in implementing these solutions that their money develops. They need to treat it more like they need to be a little bit more invested in deploying the solution that they discover that is a success, and establish some ownership for that, from my perspective. And it's pretty much everywhere. Public-private partnerships are complicated, and I don't want to oversimplify them. But when funding from local, state, and federal regulators funds solutions that are proven to work with their own teams and experts that are involved in the project, from the state and local level, I think there's some room for improvement on how do we take these solutions? And this hasn't really we're kind of entering a new era where we have these problems that are big enough that we need more funding and we need help getting distribution and getting market validation. And, coming from the local, state, federal regulator as a partner in a public-private partnership that provides environmental and economic benefits, I think we could do a little bit better and leaning into that and navigating that. It's a very fine line, I understand, but that's where I see.
Thank you so much again, Parker and Joel, for being here to share your perspectives. And thanks so much, Sylvia, for doing the same and for moderating us through a really interesting discussion. Really appreciate everyone spending time with us here today. We will share out, we heard from a couple of folks a request for the recording that will be shared out with everyone who's registered. And yeah, please do feel free to follow up with all of our panelists if you're interested in learning more about your solutions. Thanks one more time to Cleveland Water Alliance and to the Great Lakes Commission's HABs Collaborative for putting this on. And with that, I hope everyone has a good rest of their day.